Now that we've covered the special angle pairs that happen when you have parallel lines from section 3.2, we're going to flip that around, and in 3.3 we're actually going to prove that the lines are parallel. So we're going to use those same certain angle pairs to decide whether two lines are parallel. And notice that we have this word converse coming first. We've seen that word before. So converse, remember, it means we're flipping a statement. So last time when we said corresponding angles, when they're congruent, if the lines are parallel, we're just flipping that around. So if two lines in a transversal form corresponding angles that are congruent, that way we can tell they're parallel. So again, in the last section, if I started with the lines being parallel, we showed that the corresponding angles were congruent, 2 and 6 there. But now I'm just changing that. So now I start with the fact that there's a congruency there. 2 and 6 would be congruent. So that would show me that those lines are parallel. Again, a converse just means that I'm going backwards from that earlier statement that we have. So along that same line, if I'm doing the same idea but with alternate interior angles, so alternate interior angle converse, if two lines form a transversal and alternate interior angles are congruent, then I also know they're parallel. So again, we had that connection from before, alternate interior angles, 4 and 6. This time, if I start with them being congruent, then I'm using that to show the lines are parallel, so not the other way around like 3.2. Same thing, we have same side interior angles just like before. And I made a mistake and wrote congruent again, but remember, two lines in a transversal, if they form same side interior angles, those aren't congruent. Those are your supplementary angle pair. That can also show two lines are parallel. So if I have same side interior, 3 and 6 here, if those add up to 180, that means they're supplementary, so that would also prove that L and M here are parallel. And last connection, we also had alternate exterior angles before. So same thing, if two lines in a transversal form alternate exterior angles that are congruent, I also can use that to show that the two lines are parallel. So if I have alternate exterior angles here, 1 and 7, if I find that those are congruent, that's enough to show these lines are parallel. So again, all these rules are pretty much just backwards of what we had in 3.2. Trying that with some practice, which lines are parallel if 1 and 2 are congruent? So again, 1 and 2 being congruent here, that would mean that we have corresponding angles to show that lines B and A, or how I wrote it, A and B, would be parallel. So line A, line B, if I use those two as my parallel lines, that would mean that these two are congruent. So if I know they're congruent, I know they're parallel by the corresponding angles. Again, converse we add in because we're flipping that rule from before. So which lines are parallel if 6 is congruent to 7? So 6 and 7 being congruent, those also look like they're corresponding. So if corresponding angles are congruent, then these lines L and M would have to be parallel. So L is parallel to M by the corresponding angles, again, converse, because we're changing that statement to read backwards. It's a little hard here to, I think, see the angle labels in problem 2, but if I see that I have angle 1, angle 2, and angle 3 here, if it's made up with a fence with that sideways, looks like our transversal here going through those posts, if 1 and 2 are congruent, so angle 1 congruent to angle 2, we could tell that lines R and S are parallel, so two of those posts that form angles 1 and 2, because angles 1 and 2 would be alternate exterior angles. So if alternate exterior angles are congruent, then I know that the lines are congruent, remember, by the converse, because if I show that 1 and 2 are congruent there, that would only be true if these were parallel lines. And if we try and show that another way, we could involve angle 3 there. So I could say if 2 and 3 are congruent, we know they're congruent because they're vertical angles, so 2 and 3 would have to be congruent. Then we would also know that 1 and 3 are congruent because we've already shown that 1 and 2 are congruent. So if 2 and, if 1 and 3 are both congruent to angle 2, then they must be congruent to each other. That's the transitive property. So 1 and 3 would be congruent to each other since they're both congruent to angle 2. And if I know that 1 and 3 are congruent, then I could also show that R and S there are parallel because now I have the corresponding angles being congruent. So that would be corresponding angles converse. So trying some of those down below with some expressions. Again, give yourself a shot. I know I have some of that started there, but let's see if we can find some values of x. So first question, find the value of x that makes A and B parallel. So A and B. If x is going to, if I'm going to find the value of x there, I know these are same side interior angles, so I know that they should be supplementary if they were parallel. So that's the equation I'm going to set up, 2x plus 9 plus 111. If I add those two, since they're same side interior, they're only going to be 180 if those lines are parallel. So we want to set that equal to 180. After that, I'm just combining like terms. 9 plus 111 is 120. subtract 120 from both sides, and then divide by 2, and it looks like x would have to be 30. So along those same lines with that next practice question, and again, try to go through that before we get to it. If I want to find the value of w that makes c and d parallel, that means this time that they're not going to be supplementary, because this time it looks instead like they're corresponding angles. So if I want to show that these two lines C and D are parallel, that means that 3w minus 2 should be the same as 55. So 3w minus 2 should also be equal to 55. Those two should be congruent. So if I add 2 and divide by 3, I get my solution for w. That should be 19 there. So problem 4 is a pretty good recap of the difference between the two uses that we have. The alternate interior angles theorem, so this is what we had in section 3.2, and the converse of that alternate interior angles theorem, so that's how 3.3 is changing. We're going to use that original alternate interiors angles theorem, so that's, again, when lines are parallel, that means that alternate interiors are going to be congruent. We use the original when we try to show that the angles themselves are congruent, and we're going to use the converse when we know the angles are congruent and we're trying to show that lines are parallel. So again, those two are just kind of reverses of each other. Whenever we're using the converse, we're using that to show lines are parallel. And that's going to apply to our last proof, so it's always a good idea to try that first, but let's see what we got for that proof. Oh, if I can find that. So if I have L and M that are parallel, that's given, and I can also notice these little arrows here in the diagram, also telling me that those are parallel. Angles 1 and 3 are congruent, so if I know that 1 and 3 are congruent, you could also mark that in as far as your arc markings. I know that 1 and 3 are congruent. So I'm going to be able to use that to prove P and R are parallel. So these two lines should also be parallel. So first thing is I'm going to label one part of that given. I don't think I need both yet. And I use the fact that L and M are given because for our next statement, if I know, I'll clear some of that writing out of the way first. If I know that L and M are parallel, that means that angles 1 and 2, if they're in corresponding positions, they should be congruent. So angle 1 and angle 2 are congruent because corresponding angles are congruent. And you could probably also add in there before that you say corresponding angles are congruent that this happens when you have parallel lines. So if you have parallel lines, that implies that they're congruent. But if you have something just like this, I would know what you're meaning there. So now if I know that 1 and 2 are congruent because these are corresponding, I'm going to throw that other given in there. So again, sometimes you can space out your given. It'll make a little bit more sense. And now I can see with steps 2 and steps 3, since angle 2 and angle 3 are both congruent to angle 1, they must be congruent to each other by the transitive property. And that's of congruence here. So angle 2 congruent to angle 1, angle 3 congruent to angle 1. That means 2 and 3 should also be the same. So now that I know that 2 and 3 are the same, if I look back to my diagram, it looks like 2 and 3 are in alternate exterior positions. Again, exterior because they're outside of the lines P and R. P I had the label there because it didn't have a label. And alternate because it's on opposite sides of this transversal. I have 2 on the left-hand side, 3 on the right-hand side. So alternate exterior angles, if I know that they're congruent, so I already had a step saying 2 and 3 were equal, or yeah, congruent I guess. If I know that those two are congruent, I can show that P is parallel to R by using the converse of your alternate exterior angle theorem. So I just kind of said if alternate exterior angles are congruent, that implies the lines are parallel. And again, you could also use the phrase alternate exterior angle converse because that's what we mean to show that the lines are parallel. Remember, whenever you're showing that lines are parallel, you want to be using a converse. So go ahead, give it a shot, and come in to next class with questions.